Introduction to Python program. Now, Python is by far the most popular and the most in-demand programming language in the world. Most of the new jobs which are coming into the market are in the domain of Python program. Whenever you want to do any kind of data analytics related work, or you're looking at any kind of data science related work, you are going to be looking at Python. This is the importance of Python in today's society. But the thing about Python is, right, whenever I have seen people post about Python, or whenever I've seen people utilize Python, what I've realized is that nobody's talking about the introduction. Everybody is jumping into the programming. Everybody is expecting that you have some base level of knowledge with you. But what if you don't have that base level of knowledge? Is that a wrong thing? Obviously not. Nobody was born a Python expert. Everybody became a Python expert, or they became good with Python. Okay. Now, today what we are going to do is we are going to introduce ourselves to Python programming. We are going to talk about some basic aspects of Python, and we are going to see what are the different things which we can learn as part of our Python program. Okay. We are going to look at the different tools which we can use in Python. We are going to learn about some most popularly used IDEs, and then we are going to look at some programming aspects of Python. So, in front of you on your screen, you're seeing an application which is open. Now, what is this application that we are looking at? This is known as Anaconda Navigator. Anaconda Navigator is a very useful application which allows for Python integration with your system. Anaconda will ensure that Python runs on your system without any problems. Okay. This will ensure that you don't need to have a local version of Python, because Anaconda will provide you one. So no local version is required. Okay. So this is why we are using Anaconda, and Anaconda Navigator is very straightforward and it is very, very easy to use. Okay. It's very straightforward and very simple to use. Okay. So this is the purpose for our Anaconda Navigator. Now, within Anaconda Navigator, we can create something known as environments. Okay. So environments are isolated versions of Python. And these isolated versions of Python will allow us to utilize a lot of different tools without these tools interfering with other existing versions of Python. Okay. Everything is going to be in a whatever I do in one of the environments of Python is not going to have any impact on the other environment. Okay. So this is the first major benefit that we get from using Anaconda Navigator. No other application will provide you with such a useful mechanism. Okay. Then it will also give you various different IDEs. IDEs are integrated development environments. Now, these IDEs are designed to help you run Python codes. Okay. So, using these IDEs, we can figure out what kind of Python code we want to write. We will look at two major IDEs today. We will cover Spyder and we will cover Jupyter Notebook. But first, let's talk about creating these environments. Now, the benefit of using Anaconda is that everything you do with an Anaconda is available on the UI itself. So this is my home page, and this is where my environment is going to exist. And these are the only two tabs that we need to worry about. We don't need to look at learning or community unless you're specifically asked by someone. And since nobody will ever ask you to do these things, we don't have to worry about looking at it. Okay. So we have the environments here. Here you can see that there are multiple environments already created. So how can I create a new environment? How to create a new environment? It is actually very, very straightforward. It's a very simple task. Okay. So we will click on create here. Okay. So we have this option of create. Okay. So here, what do I need to give? I need to provide only two things here. I need to give the name of the environment. Okay. And I need to give the Python version. We don't need to use this. Okay. This is not required. Okay. We can just directly focus only on the Python as well as the name of the environment. So let's give a name here. Let's say that I give this some name. And then I select the version of Python. Which version of Python you will get? Which version of Python to select? Okay, this is the next question. Which version of Python to select? This is the question. Here, we have multiple options for selecting the different versions of Python. Okay. Most of the time, we can just use one of the latest versions. Okay. So as a recommendation, I would say that you can go with 3.9 or higher. Okay. Everything below 3.9 is gonna have irregular updates. So it is better that we stick with 3.9 or higher. Okay. So here I will select whatever is the pre-default version selected and I will just click on create. Okay. Once you create the environment, it will install the necessary requirements. Okay, it will install all the necessary requirements. Okay, and you can see the environment is already created. It did not take us more than 2 minutes. This is the benefit of using Anaconda. Okay, so a skeleton environment is ready for you. And now all we have to do is we have to design this environment. Okay, then this is our environment. And this is basically like a blank environment where you can install whatever tools you require. Now, Anaconda by default is going to allow you to integrate many different tools depending on your work. For example, it supports external tools such as VS Code. Okay. It also gives you tools like Jupyter Notebook and Spyder. Okay. So what we will do here is we will install Spyder first. Okay. How do I install Spyder? That is the next question. Here, if you click on this little icon here, okay, you can just install the application, or you can select which version you want to install with. Usually it is okay to go with the latest version. We also have this install option here. So I will click on install. Now, each environment of Anaconda requires its own IDEs. What does this statement mean? This statement means that we are going to take a look at all the possible different environments that we have. Okay. And then we are going to be looking at the isolation aspect of this. As part of the isolation aspect, what are we looking for? As part of the isolation aspect, each and every environment is not interacting with one another, right? So therefore, it is important that we install the necessary tools. Okay. Similarly, I will click on install for Jupyter. And while Jupyter is getting installed, we will start a Spyder. Now, let's remove all of these files. Don't need that. So this is what a blank file in Spyder will look like. Okay. Now, here, this pane that is, let's highlight this quickly. Okay. This is known as this is a code editor. Okay. This is where we are going to write the code. Okay. This part of the screen is where I'm going to be writing my code. Then this is known as the console. The console is where your code is executed. Okay. This is basically like an interface of the command line within your Python environment. Okay. Python gets executed in the command line. Okay. So that's why tools like Spyder will integrate command line in their UI. Okay, and this is how you will get your running of the Python codes. Okay, so now let's write a code. So I will say something basic like 2 plus 2 here. Okay, this is all I will write. Now, other programming languages will require you to create some basic skeleton within which your code needs to fit. Okay, but Python does not require that because all of those processes are happening in the background. Okay, so instead, you can just directly write whatever code you want to write. Okay, so this is the benefit of using our Python. Compared to some of the other programming languages, this just makes your life easier. Okay, so then how do I execute this? The execution is very straightforward. We have this option right here. Okay, if you hover over whatever line you want to, if you select the line that you want to run, let's say that I want to run this line. My cursor just has to be on the line. Okay, so all I need is my cursor on the line. That's it. Nothing else. Okay, so I will run this and I will get the output here. Okay, as you can see, the output is available here. So this is the first thing. Okay, then the next thing that we have here is something called as variables. Now, variables, they act as memory pointers. I will explain what is the meaning of memory pointers in a little bit. Okay. But for the time being, we just need to go through some rules of variable creation. So, what are these rules? The first rule is that it must be alphanumeric. Okay, so it has to be alphanumeric in nature. Okay, then the second thing is that no special characters except for underscore. Then the next thing is it should start with an alphabet or underscore. Okay, and Python has certain keywords which it keeps for itself. So no reserved keywords. Okay, This is how our Python is going to create variables. Okay. So let's say that I have some value called 5. Okay, I will write 5 here and done. That's it. This value is there. Now, what I want to do is I want to store this value. Okay, I want to store this value somewhere. So how can I do that? What can I do to store this value? I can use variables. Okay, this is what I can use variables. Okay, so by using these variables, I can ensure that by using these variables, I can have what I call as memory pointer. So let me explain what is this concept of memory pointer. Okay, we have a box here. This box represents the system's RAM. Now we are not going to go too much into how the RAM works, how the system works. Rather, we are going to look at how Python interacts with the RAM. Okay, let's say that we have some value here, which I want to store. Okay, this value can be anything. It can be something as simple as 5, or it can be a very complex value. Okay, so what this value will be doing is it will be placed in the RAM. Okay, now what is the meaning of this? Keep in mind that if you need to use any value or data in Python, it should be stored in the RAM. Okay. If you need to access any value within Python, you cannot just store it anywhere. It has to be stored within the RAM itself. Okay. It cannot be stored anywhere else. It cannot be used anywhere else. Okay. You have to do it within Python and within Python alone. Okay. This within the RAM itself. This is a requirement. Okay. Then when you store this value in your RAM, it will be assigned whatever is the next available memory slot. Okay. Your RAM can be of any size, but it will always be divided into smaller parts. And it can, it will be stored in that specific location. Okay. It is always stored like this when it comes to our Python. Okay. So now here, this memory location will have some memory position. Okay. So what is this memory position? Memory position refers to the exact location of memory. Okay. Now, this is usually some kind of hexadecimal value, which is probably not required for us to know. Okay. So when we are using this hexadecimal value, Okay, we are going to be looking at how I can make it easy for me, for the person who is writing the Python code, to access that hexadecimal value. So what we will do is we will give it a nickname. We are going to provide it with the nickname. This nickname becomes our variable. Okay. So this is what we need to do. So if I want to store any value, then I need to give it a name. So I can say a equals to 5. Okay. And then if I say, for example, print a, I will get the output of 5. Okay. So let's say that I want to understand my variable naming convention, right? As I mentioned, your variable has to be alphanumeric, and as long as it is alphanumeric, you will not have any issues. Okay, it will work regularly. Now, what if I write it with this? We are going to run into a problem. We are going to run into a syntax error. Okay, so this is something that we need to make a point of. There. As you can see here on the Spyder, you will notice that in whichever line you run into any error, a red cross appears. This is to act as a guidance, or you can say this is like a warning system. Similarly, here also you will get an error. Okay. So this is how Python, specifically Spyder, will tell you that you have made a mistake. Okay. So now let's see. We also talked about special characters, right? So when I say a, let's say a underscore 1234 equals to 5. Okay, you can see that no error message is coming. So we will say print a underscore 1234 equals to 5, and we will get the output. So that means the underscore character is not allowed. Okay. Now the question that must be coming to your mind is that, okay, if the underscore character is not allowed, then what is allowed? If the underscore character is allowed, why are the other special characters not allowed? Because those other special characters will be used for different things within Python. Okay. So if I say a, let's say at the rate 1234 equals to 4, I'm getting a error. Okay. I'm getting another syntax error. Then if I say a, let's say a 1234 equal to 4, again, I am getting a error. So because these special characters are designed for doing some other task. Okay. So this is the first thing. The second thing that we are looking at is, what if I add the special character in the front? Again, I'm getting an error. Okay. Or if I say 1, 2, 3, A equals to 1, again, I am getting a error. Okay. So you have to be very particular about giving your variable names. Okay. You have to ensure that whatever variable names you are giving, they are in the correct format and that they have the logical name. Okay. So this is related to a variable name. Okay. Now Python has various different data types. Okay. And in order to look at some of these data types, let's explore Jupyter Notebook. Now I'll open Jupyter Notebook and I'll show you how to use Jupyter Notebook as well. So this is the page for Jupyter Notebook that will open for you. Okay. And this is your local file system. And this will also show you if there is anything that is running. Okay. So let's open any one of these folders. Okay. So I'm in the local folder here. Then what I'll do is I'll have options. Okay. So when I click on this new button, I will get a bunch of options. So what I want to do is I want to select this Python 3 IPY kernel. What is IPY? Dot IPY. This is interactive Python. Okay. So I want to look at interactive Python. So I'll click on IPY kernel and it will open a Jupyter notebook for me. And this is what Jupyter notebook looks like. It's very clean, a very sleek design, which is created to help you understand what kind of data it is that you're looking for. Okay. There. Let's look at some data types. Okay. So we have two basic data types. So if I say, let's say A equals to 5 and B equals to 3.0, what I can do is I can say print type A. Okay. So we are looking at something known as functions. All right. So alongside the variables, we will also explore these so-called functions. Okay. So we have functions like print and type. What is print going to do? It's going to give the output on the console. And what is type going to do? This is going to tell the data type. Okay. So this is how our Python function will do. Okay. Then here I will also say print type B. We will get the output. Now we got the output without clicking anything because in order to execute anything in Jupyter Notebook, first of all, let's look at the nomenclature. So this in the Jupyter Notebook is what we consider to be a cell. Okay, so Jupyter is consistent of smaller individual cells. Okay, and if I want to execute any specific cell, I can use, say, shift enter. When I press shift plus enter, it will execute that cell for me. Okay. Now, what do we see here? Output int float. Int refers to integers, float refers to decimals. So integers will contain integer value, okay, and float will contain decimal values. Okay, so anything with a decimal point is known as a float value. You can obviously convert any numerical values within one another. Okay, so this is the first data type that we have. Let's look at another example here. I will say print type, and I will mention the word to, and I'm getting class bull. Okay, now what is bull? What is true? There are two unique values, which are known as true and false. These have their own data type, only true and false, by the way, nothing else. These have their own data type, which is known as Boolean, and it is represented as BOOL in our Python. Okay, so this is the basic requirement that we have. Okay, next, let's create a variable called st, and let's add double quotes here. And within st, I'm going to just write a small text. I will say that I really enjoy working with Python. Okay. Now, the double quotes here mean that it is a data type which we commonly refer to as string data type. Okay, this is commonly referred to as the string data type. Okay, so let's execute this. Let's look at the type. What we are trying to identify here is how is this data type showing up? This is showing up as str. Now, string is one of the most common ways in which our data type, our data is stored using Python. Okay, so let's create another string. Okay, and let's say I really enjoy working with Python. I hope you like Python too. Oops, I'm getting an error. What is the error here? I have created something that is known as a multi-line string. Okay, so what do I do with a multi-line string? Should I just write everything in a single line? But what if you have thousands and thousands of words? So in that case, what I will do is I will create the string again. And instead of using single quote, single double quotes, I will say 1, 2, 3. I really like working with Python. I hope you enjoy it as well. This is an example of multi-line strings. Okay. And again, I'm getting an error because at the end of my string, I need to do 1, 2, 3 and done. And then I can simply say print D. I will get the output. Okay. So this is how strings work. Now, since this is a multi-line string, does it mean that this string is somewhat different? Okay. So instead, we will just simply say print type D and we will print the statement. And you can see here that it is still the same way. Okay. This is how our data type in Python is going to work. Okay. Now, we have a few more data types which we will cover. Okay. So let's take a variable called li. And then what I'll do is I will use square brackets. And within square brackets, I will enter some values. And then I will close it with the square brackets. Right? And then let's print and understand what exactly it is that we are dealing with here. We are dealing with something known as a list. Now, list is another data type in Python. This is very flexible, so it is very commonly used in Python. This allows us to store different data types. So you can store multiple data types within your list. Then it also gives you the option of modifying the list. Okay. You can modify list differently. Okay. So this is what a list is. All right. And it is stored within the square brackets. Okay. So this is the next list. Okay. Then let's say we have another variable called tu, and this time I will store it in parentheses. When I execute this, this is known as a tuple. Okay, this is another basic data types. It is quite similar to the list. The difference with tuple is that once you modify a tuple, you cannot change it. Okay, once you once you create a tuple, it cannot be modified. Okay, now there is a very big explanation about it, but essentially what you need to remember at a basic level is once a tuple is created, no modifications are allowed. Okay. Now let's look at some more complex data types. Okay. Let's say that I have this list li and I want to access the values which are stored in this list. So what I'll say is print li, right? This is the basic statement that we have covered so far, right? So when I say print li and I execute this, I'm getting the entire list. But what if I want to access one value at a time? Okay, that cannot be done with a list directly. So what do I need to do here? I need to do some very basic operations. I can say for I in li, and then I will say print I. This is known as a for loop. A for loop is any loop which will allow us to access values without having where you cannot access the values directly. Okay. So we have a terminology called iterables. Iterables refers to the different types of data type where you cannot have direct access to the values. Okay. Wherever you cannot have direct access to the values, that is where the for loops come into the picture. Okay. Then similarly, I can say print tu. Again, it is printing like this. So maybe I'll say for I in tu, print I, and we get the answer. Similarly, if I say print d, I get the string. And then I can say for I in d, print I. And each and every single element, including the spaces, is printed here. Okay. This is how our for loops in Python will work. Okay. Now, we can use for loop for various different things. So let's take an example here. Let's say A is a list called 1, 2, 3, 4. Okay. And B is another list called 3, 4, 5. Okay. Now, what if I do A plus B? What will happen is it will just combine the list together. Okay. It will not do the actual multiplication. Let's take another list C, and I will just put the square brackets. When you put a square bracket, it just creates an empty list. So if you see the print statement here, it's just an empty list. Okay. So what we will do here is we will say for I in A, for J in B. Okay. X equals to I plus J. Okay. Sorry. And then I will say C dot append. Append means add it in the data. Okay. So then we run this, and then what we will do is we will say print C, and we will get the output like this. Okay. So it will add the elements of A to the elements of B, and it will return the output. Okay. If you want to store each and every value, so then what I'll do is I will rerun this line. Okay. And again, I have this, and I'll just hit tab, and I will add this value here. Okay. And we will get the output like this. Okay. This is how our lists are going to work. Now, the final thing that we are going to look at are known as conditional statements. Okay. What are conditional statements? And what do we mean by these conditional statements and how are these conditional statements going to work. Okay. So let's say that A equals to 5, B equals to 1. Okay. Now, I want to print something. I want to see for how long will B be greater than A. Sorry, A will be greater than B. Okay. This is what I want to see. Okay. So what we will do here is we will say if A greater than B, can say print A is still, and when you're adding a print statement, make sure it is a string. And then I will say B equals to B plus 1. Okay. Then next, I'll say else print now B is no longer smaller than A. So I'm just giving a message here. Okay. So let's run this. And we will get the output. It will continue to have, it will only give you one output because it is only designed to run the conditional statement once. It cannot run it multiple times. Okay, solely designed to run it once. Okay, so what we will do here is we will try to integrate for loops and we will try to integrate conditional statements together. Okay, so we'll say for I in range, let's say some value, or we can say instead of using while, instead of using the if statement, what we will do is we will use something known as the while statements. Okay. We will say while A greater than B, print A is bigger than B. And then after the statement, I will say B equals to B plus 1. Then I'll say else print B is no longer smaller than A. And you can see that as long as it is meeting that condition where B is greater than 1, okay, it is continuing to print the original statement. Okay. This is how our conditional statement works. Okay. So this is how our Python functions. This is the basic process that we follow for whenever we are using Python. So let's quickly understand what we have covered today. We have talked about the introduction of Python. And specifically, we were talking about why we need to do Python. Okay. The reason for doing Python is very straightforward. It is in demand. Everybody wants Python expertise or familiarity Python. Okay. So this is an important requirement, and that is why we are talking about Python. Then we looked at Anaconda navigator. Anaconda navigator is an important tool for Python development. It is probably the most important tool in the ecosystem of Python development for various different reasons, of course. It's not just one thing, but it is a combination of various different. Okay. This is also very important. Then we looked at the concept of environments, why we need environments and what is the use of environments. And then we looked at how to create environments. Okay, this is what we have looked at. Okay, then we looked at Spyder. Spyder is what we call as an IDE. Okay, and as part of Spyder, we were exploring variables. We understood why variables are called as memory pointers. And we also explored the different rules which are required for creation of these variables. Okay, which is again an important task. Then we looked at Jupyter. Okay, now Jupyter is a second IDE which is available to us. Okay, this second IDE is also a very, very important IDE. Okay. Now, what is this IDE used for? What is this going to work in? This is going to work as an interactive Python notebook. And this follows the concepts of something known as cells. And we saw how we can execute these cells. Okay. So this is how our Jupyter works. Within Jupyter, we looked at quite a few things. We looked at what are the different data types which we are going to cover. So we looked at some examples of the most commonly used data type. Okay, things like integer, float, etc. Okay, we also looked at Boolean. We looked at list and tuples. We also understood what are strings and we understood what are multi-line strings. We then used the print and the type functions within Python to understand what is the different data types. And then in order to enhance our learning, we looked at things such as for loops, if statements, as well as the while loops. So these are the different kinds of loops and the conditional statements that we have. Okay, so this is all we have for everyone today, folks. Thank you so much for joining in. I'm really glad that we could have this class and this webinar together. And I hope that something like this inspires you to take up Python. Thank you so much for everyone who has joined in today. And thank you so much from everyone in who has from thank you so much for everyone from 360 Digit MG. And we hope to see you for our next webinar. Thank you guys and have a good one.